Yeah, let me share the screen first. Here you go. I hope you can see the notes. Okay, see my notes. Um, so actually, the correct section should be 10.2. Okay, so you can see in the canvas it's 10.2. Okay, um, we discussed 10.1. This is 10.2. Actually, we did this section last Monday before the Thanksgiving. Okay, so we that's the last day we met last Monday. We discussed counting rules, and you can see I posted a practice problem for final exam. So let me show you that one as well. In Canvas, you can see that practice problems cover everything you learned so far. Okay, it probably, it's pretty much cover all three tests, including, you can see I put one question from the things that we currently learning, permutation and combination. Okay, so so that means this question number 7 uh, you will get from section 10.2, the things you are learning from this section. Okay, um, so I'll quickly remind you, as I everybody came last Monday, so but let me at least go over the idea for the permutations and combination idea. Okay, that's the important thing. I'll quickly go over. So if you have a situation, so I divide into 5 rules. Okay, if you have a situation like certain things happen many times, and each time you have same number of options. So you just multiply how many options you have until how many trials you have. Okay, so that's, for an example, if you toss a coin 3 times, each tossed has 2 options, head or tail. You toss it 3 times, so these are called trials. Okay, each time you have 2 choices, so 2 times 2 times 2 is 2 to the power 3, which is 8. So that means how many different possible outcomes you can get if you toss a coin 3 times. It's 8 possible outcomes. If I ask you, I think I listed them in there. So if I ask you to write down all the possible outcomes, if you toss a coin 3 times, you can write, okay, you can get head, 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 or maybe tail, 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 head, head, tail, maybe head, tail, head. It's a two, these two are different. Okay, you get same number of head and same number of tail here. 2 heads in both cases, but it's in different order. Okay, order matter here. So tail, head, head, tail, tail, head, tail, head, tail. You may have daylight, tail, tail, head. No, right? Tail, tail, head. So these are the 8 possible outcomes. Most of the time, you don't need to list everything. You need to tell me how many possible outcomes. That's, how much, because list them all is kind of time consuming. Okay. And the next situation in rule 2 we discuss in our real world, it's not all the time we have 2 options. Like tossing a coin, you have always 2 options in each trial. But in this situation, like if you have a different options, like to choose 3 parks, 4 restaurants, and 6 movies to choose, then it's 3 times 4 times 6. So there are 72 different ways one can go to a park, eat at a restaurant, and see a movie. Okay. Similar way, I can discuss, if you have, if you go to a restaurant, or maybe let's say you go to a Pizza Hut or Domino's, you wanna order a pizza which has different toppings, 4 toppings, let's say, and if it has 5 different type of sauce. And what else? You have toppings, sauce, and maybe 3 different bread types. Okay, so then it will be 60 different ways you can order a pizza. Okay, that's rule number 2. In rule number 3, I introduce factorial, which is operation. Like if you want to calculate 4 factorial, it's 4 times 3 times 2 times 1. Okay, it will be 24. Note that 1 factorial is 1. 0 factorial is also 1. This is sometimes students think it's 0 factorial is 0, but it's not. 0 factorial is 1 by d. Okay. There are situations you can simplify factorials. For an example, if I ask 8 factorial divided by 6 factorial, you can write 8 factorial as 8 times, 7 times, 6 times, 5 times, 4 times, 3 times, 2 times 1. 6 factorial is 6 times, 5 times, 4 times, 3 times, 2 times 1. But you can see this is 6 factorial and 6 factorial cancel out. So it's just 42. Okay. So this is how I write it. I can write 8 times 7 times 6 factorial, and it divide by the 6 factorial in the denominator. Okay. So if you have factorial division, you better cancel them out before doing all the multiplication. Okay, because you can't use the calculator. So this idea is very beneficial. Okay. Right. Now, why we need factorial? What are the application we can we can learn from factorials? Where the factorials occurs in our real life. If you think you need to arrange 3 letters, you can think it's like you need to make a password, but you can use only 3 ABC letters. How many different passwords you can make? Okay. So in that case, you have 3, the length is 3, or because it's just 3 letters. So for first letter, you can use anything, A, B, or C. It's 3 options for first. And if you use 1 letter for the first position, there are 2 other letters remain. Let's say you put A for first, and you have B, C. You can choose anything. So 2 options. Once you use a letter from B or C, you can have only 1 letter. This is like exactly 3 factorial. Okay, and its answer is 6. So these are the 6 different ways you can arrange 3 letters. There are 6 different passwords you can make using 3 letters. Okay. So because it's like each time you reduce an option because you use that. Okay. So this is kind of an idea how to find the number 6. This is the list, the exact list. There are 6 ways you can arrange 3 letters in order. That's 6. How about if you have 5 different books to put on a bookshelf? How many different ways these books be placed on a bookshelf? In a bookshelf, you can think, okay, this is a bookshelf, okay, and you have 5 letters to put, 5 books to put. For first place, you can put any book, 5. For the next position, you put a book here already, so you have 4 books available. You can put anything here out of your 4 books, right? And if you put 2 books already, so only 3 options could go here, and so on. You get 5 factorial. This is a nice thing. Sometimes you may think, if you have a situation, I'm not sure in the class I mentioned that. Let's say you have a situation that there are 4 positions in a committee, but 10 people 10 students in the class, but I need to select only 4. Okay. Right. So you have 10 students in the class. I need to select 4 people and arrange them and get a different photographs. Or you can think you have 10 different letters you can use. Okay, there are 10 letters available, but you choose 4 and arrange them. Okay, so only four different vacancies we have. For first vacancy, you can use 10 because there are 10 students or 10 letters are available. For the next one, you have 9. The next one, you have 8. For the next one, you have 7. Okay, so that's really what you are doing is you make permutation 10p4. So you choose 4, you choose and arrange them. You not only choose but arrange them. Okay, so this is a 4. This is 4 people. Okay? So the best example is like you can think you have 10 letters. You can use 10 letters, but you need to make a password with 4 string, length 4 passwords. How many length 4 password you can make out of 10 different letters? So you see here, really what the answer is, you can get from this definition. So you take the 10 factorial and take the 10 minus 4, which is 6 factorial, because you have to take the difference between 10 and 4, which is 6 factorial. And if you remember last time I told you 10 times, 9 times, 8 times, 7 times, 6 factorial you can cancel out with the bottom. Okay? So that is exactly what we had. Okay? So permutation is really, you don't need to select all the 10 possible letters to make the arrangement. You can select something out of the 10, like 4, and arrange it. Okay? Here I got 5 factorial exactly because I choose all the 5 different books I have and I arrange them on a bookshelf. Okay, if you have 5 different books on the table, but you can how many ways you can arrange only by selecting 3 books, then it's 5p3. Okay, then it will be 5p3 because you have 5 books, but you only choose 3 and arrange them. You can choose different ways, 3 books out of 5, and then you can arrange. So if you want to find that, it's 5 factorial. The difference of 5 and 3, 5 minus 3 is 2 factorial. So you get 5 times, 4 times, 3 times, 2 factorial you can cancel out with the bottom. So it will be 60 different ways. You can do that. Okay. Right, let's do another question. Right. So consider you have 4 letters available. You have to select 2 and arrange them. So you see here what really the interesting thing is you can select AB and arrange them. See, you select AB and arrange. You select AC, the letter A and C, you can arrange them AC or CA. You can choose the letter AD and arrange them. You can select the letter BC and arrange them. BD and arrange them. CD and arrange them. There are really 6 different choices. So you have 4 letters. There are 6 different ways you can select 2 letters, but you arrange each one 2 different ways, A, B, B, A. A, C you select, and there are 2 different ways you can arrange AC. The first is AC, the other one is CA. Okay, so it's 6 times 2 is 12. Right? But you can quickly get it by 4p2. 4 factorial, 4 minus 2 factorial, which is 2 factorial. 4 factorial is 24. 24 divided by 2 is 12. Okay. So I talk about here you select some number of different items from a big number and arrange them. Okay. So if you don't arrange them, if you just worry about selecting objects, not you are not considering the order. Order doesn't matter. Here, order matter. Okay? Order matter. But if you don't consider the order, if order does not matter, you just select, then there were 6 possible ways you can select 2 letters out of 4. So that's what we call combination. So we use C for that. So for an example, if you select only 2 letters out of 4, it should be 6 because that's how many circles I got here. So for this case, you take the 4 factorial, you take the difference, okay, which is 2 factorial, and you divide by the 2 factorial as well, again. So it's like you divide 12 by 2 again, and then you get 6. Okay, that's how you got 6. So this is the example we discussed here. If you only select 2 letters, you don't arrange, you just select AB. You select, but you don't write ABBA because I don't consider like arrangement. It's like, let's say you have 4 books available. You want to select 2 books in a given month. How many different ways you can select 2 books out of 4? You are not arranging them. Okay, you can think, okay, there are 4 math courses available next semester, and you need to select 2 math courses. So there are 6 possible ways you can select 2 math courses out of 6 possible courses. Once you select, let's say, discrete math and calculus, that's it. It doesn't matter, order, because you are taking the both classes. It doesn't matter the calculus is in the morning or the discrete math in the afternoon. It doesn't matter the order. You're taking it. Okay. You have 5 books and going to select 3. So let's say this is, let me, I think last Monday, I think I wrote down. If not, let me explain. Like you can think, oh, you have a history book, business book, math books, physics books, and a chemistry, computer science book. Okay, how many different ways you can select 3 books? Okay, I can select history book, business and math book, history, business and physics book, history, what is that? Yeah, business and chemistry book, history, math and physics book, history, math and chemistry book, math, physics and chemistry book, business, math and physics book, business, math and chemistry book, math, physics and chemistry book, history, physics and chemistry. These are the 10 different ways I can select 3 books out of 5 books. Remember, I choose history, business and math. I will not write math, business and history. Of course, it's a different arrangement. If it is a password, it really matters because in the password, the order matters. But when I read 3 books, it doesn't matter the order. I just select the 3 books. That's it. Okay. Right.